Hello everyone, welcome back to another video. So today we'll discuss editorial for weekly contest 402 of Leetcode. And as I was able to solve all four problems, so I will try to explain editorial for all four problems. So we'll start with first problem. So there are two parts of first problem only the differences between constants. Still I will explain first problem separately. So we are given an array called as r's representing times in r, and we have to return integer denoting number of pairs such that I and j, where I is less than j, and the sum of elements present at position I and j, that is r's of I plus r's of j, must form a complete day. What complete day means? It means the time duration is exact multiple of 24. So this sum should be divisible by 24. Now this has very low constraints. So a normal brute force of n square would work. So let's see the code directly. So first I have declared n as size of that vector and a counter. Now I have two nested for loops. In one for loop I am iterating I, in another for loop I am iterating j from I plus 1 because I less than j, and then taking the sum and incrementing counter if its mod with 24 is 0. Pretty simple question, normal brute force solution. Now the second part of this question. So in this question the problem statement is same, but the constraints over here are bigger. So in this case, in this problem, the size of vector can be 5 into 10 raised to power 5, but in first case it was 100. That's why n square solution was working. But in this case we have to write an linear or logarithmic solution. So you must let's say there is an x and there is an y. So x is a value present at ith position and y is a value present at jth position. Now if a day can be formed using these two values, that means x plus y mod 24 would be equal to 0. Now if you have any idea about modular arithmetic, you can break this statement into these two parts, where x mod 24 plus y mod 24 mod 24 would be 0. That means this sum, in simple words, x mod 24 plus y mod 24 must be 24, because this value would be less than 24, this value would also be less than 24, and so the limit on this value would be from 0 to 46, and all the values which have mod equal to 24 would be 24 or 0. So this is what final formula will look like. Now how to solve this? Just replace this with let's say another variable such as a and b. So if I have to find a and a plus b equal to 24 or 0, what I can do is I can map all the values of b, and for whenever I am getting an a, I will increment my answer by 24 minus b. And for 0, the case would be, you have to handle that case separately. And to do that, for getting answer equal to 0, x mod 24 must be equal to 0, and similarly y mod 24 must be equal to 0. So this is the 0 case, and for 24 you have to write on a map. You have to use a map to store key value pairs. Now if you try to simulate the solution for, let's say, 11 13, when I am encountering 11, I will just increment mp of 11, and when I am encountering 13, I will calculate 24 minus 13, which is 11, and add mp of 11 to my answer. So all the occurrences of 24 minus b. So this was whole explanation about second question. You must know this basic modular arithmetic. So how code for this is, again, I declare n as size of my vector. I declared a map and an answer variable. Now what I will do is, I will first calculate a of I mod 24, then calculate 24 minus d, that means calculating 24 minus b, and then taking again mod. So taking mod again would handle the case of 0 also. So if 24 minus, if b is equal to 0, then my this function value would be 24 itself, and taking mod with 24 again, my desired value would become 0. So 0 case is handled by this statement. And finally I will add mp of d to my answer and update mp of a of I mod 24 after adding answer, because the I and j values should be unique, means they cannot be same. If there was a if they cannot if I was less than equal to j, that means same index was allowed. I would have just changed the order of this. I would just push this above. So this was second question. I would say it was pretty easy if you compare it with previous second questions on Leetcode contests. Now this is an interesting question. I would say not interesting, but a little bit annoying. So in this question we are given an array A, power, and each element represents a damage of spell, and multiple spells can have same damage value. And we are there is a fact that if the magician cast a spell of with damage power of I, they cannot cast a spell of power of I minus 2 and power of I minus 1, power of I plus 1, and power of I plus 2. So if magician casts spell 8 with damage value 8, it cannot cast uh, spells with damage value 6, 7, 9, 10, but it can cast multiple 8s. So that is an important, I would say, important instruction which you should remember, because I made mistakes. I didn't consider the multiple values of power of I, and I got some penalties. Now each spell at index can only be used once, and we have to return maximum possible total damage magician can cast. And for example, let's say the array is 1 1 3 4, maximum can be 6, Now how can 6 be produced? By casting spells at index 0, 1, 3, 1, 1, 4. Now for this type of for these indexes, if you try to match this condition, there will be no condition match, so this is an valid choice of spells, and we cannot get any more damage than 6. That's the answer here was 6. Similarly, in this case, answer was 13. So how answer came 13? By casting spells of index 1, 2, 3, which is 166. So same value spells can be cast. So first observation, let's say I have to cast a spell X. If you have any idea, the first thing which will come to your mind if you have solved a lot of DP problems would be DP solution. And the observation of DP solution is that when you cast a spell of X, cast a spell whose damage is X, its transition before it would be the previous element, which does not have any value between x minus 2 and x minus 1, means its value is less than x minus 2. So this type of transition in DP. Now there is another case also, that here there can be multiple values of same spell. So x and x can be present twice. So how to handle them? You can handle them by creating another vector which is consecutive. First of all, you need to sort the elements. So let's take second example. I will sort them. Now if I take 7 as one of spells, I cannot take any of these 6. So what I can take is the answer, maximum answer till this index. Similarly, if I take 6 as a spell, then also maximum answer could be this one. Now why it cannot be this? It can also be this, the position at index 1, but maintaining such condition is difficult, because not taking only x minus 1, x minus 2 and x minus 1, so it would form a structure like this. X, let's say this is x, and this is x minus 1, this is x minus 2, and this is x minus 3. So I have to take max of all the underlined elements. So forming this type of structure would be difficult, but instead of that, I can just consider these last elements, and I can group these elements as x into frequency of x. So this continuous continuous elements can be considered into can be maintained by a multiset. This can be ignored, and I am at this position. So this type of DP transition would work. And how to create this x into frequency of x? So for that, I created basically two vectors, b and c and t, where first I am storing unique elements in the in sorted order. So for this case, I will store 1, 6, 7, and counter I will store frequency of the element which is respective to which has same index in b and c and d. Now I will apply this DP logic on array b. So if I'm at position dp of I, one answer can be dp of I minus 1 itself. Another answer can be j, which is from 0 to, let's say, x, such that a of x is less than equal to b of x is less than equal to uh, b of I minus 2. Sorry. So I will just write it again. So this j is starting from 0 and it is ending at x, let's say. And what b of x represents? B of x represents the biggest element, which is strictly less than uh, uh, b of I minus 2. So this is I. So how can I find this? By maintaining a multiset of sliding window. Now there can be another option also by just taking lower bound of b of I minus 2, but I thought this solution first, so I just coded it. And so this is max function, max of from 0 to x, such that index position is less than b of I minus 2. So I have to take its dp, this value stored at that index, plus b of current element into frequency of current element. So this was the two transitions which were important to consider. So first of all, I have sorted the array. Then I have created two vectors, b and frequency vector. I will first push a of 0 into b and declare a current variable as which stores current frequency of that element. Now I will iterate over from 1 to n. If a of I is equal to b dot back, increment the current. Else I will push current value in CNT and new element in the vector b. So this part was about creating b and c and t. Now from here the dp would start. So I will just reassign n to b dot size, declare a vector dp, then update. So first dp element at dp of zeros, maximum answer would be just cnt of 0 into b of 0, because there is no other element present before it, so that this transition would not be valid for 0th index. Then I have declared a pointer j variable and a set. So j is just presenting the max value of x, the maximum index, which is such that b of j is less than b of I minus 2. So first of all, I am updating dp of I with dp of I minus 1, and while p of j is less than b of I minus 2, insert dp of j and increment j. Now if the multiset size is not equal to, means there are elements in that multiset, the transition would look like cnt of I into b of I plus whatever maximum answer we are getting through all these indexes. And then I will just update, else if the multiset has a size 0, that means we can initialize the elements which we are taking from this index. So the answer the choice for that would be CNT of I into B of I. And for each index I'm taking maximum of dp of I and storing it into the answer variable and finally returning the answer variable. So this was third problem. Little bit tricky, I would say, but easy. So now we will discuss the fourth problem, which is peaks and array. So a peak in array is an element which is greater than its previous and next element. So in this question we are basically given two integer arrays. First is nums and second is queries. So we have to basically process some queries and return a vector which is storing answer to a specific type of query. Now in queries there are two types of queries. First is of type 1 where we are given two indices L and R and we have to find count of peak elements in the subarray from L to R. And second type of query is updating an index value with new value. So for each first type of query we have to return count the answer and push it to an answer vector and finally return that vector. So for example, so in this problem we have nums 3 1 4 2 5 and queries are 2 3 4 and 1 0 4. So first query is updating third value with third in element at third index with 4, so 3 1 4 4 5 after updating the value at index 3. And second query is find all the peaks from 0 to 4 and there is no single element which is greater than its previous and also greater than its next. So greater here means strictly greater, the equal will also not work. So answer for this query is 0. So I'm the final output is a vector with size 1 and the element answer, the element present at that index is 0 also. Similarly, you can read this if you still don't have an idea. So let's start with understanding first observation. First observation is regarding how to keep this update, how to maintain this update. So you don't need to basically maintain it, but find how many elements are affected by changing the index, changing the value at index j. So let's say I have elements j minus 2, j plus 2. So changing this a of j means if it was previously peak, then it either would become a not it would not remain a peak after updating, or it will remain a peak after updating. So there is always a change in its property about being a peak or not for a of j. Similarly, it also affects a of j minus 1 because changing the value of aj also changes the property which is a of j minus 1 greater than a of j, which is required in for finding peak. So this change will also affect this value, but it will not affect this because this is completely related with a of j minus 1 and if there is a a of present a of j minus 3. Similarly, this would be affected because the condition for peak is a of j plus 1 greater than a of j. So if value of aj changes, this condition would also change. And this is not dependent on a of j. So basically only 3 indices are affected after changing, after updating a value at index j. So the problem is basically solved. So at start, so at initial stage, let's say I can basically count the number of peaks. I can count number of maintain a ordered set which is storing all the indices which are peaks initially. So let's say a of 0, a of 1, a of 2, a of 3, a of 4. Let's say 3, this 1 and this third index position elements are peak. So what I will do in my set, I will store 1 and 3. So this is an ordered set. Now policy based ordered set what I'm using here. So what is the difference between normal set and ordered set? Policy based ordered set, that we can get an index of this element. In normal set we cannot get the index of this element, but in an ordered set we can get this. And if you want to read about it, there is a Geeks for Geeks article on this, so blog on this, you can read it. So what it helps to find the number of elements present in a range which can be updated. Means we can erase that element, insert any new element, but we cannot do this in a vector or priority queue. So maintaining an policy based ordered set is required for solving this question. Now initially I will declare this set like this. Now whenever there is an update, I will iterate over these 3 elements first, and if they were previously peaks, then I will remove them from st, and if they then I will update the value of a of j with new value, and again iterate over these 3 values. And now if any of them becomes a peak, then I will again insert them in my ordered set. Now for queries L and R, we basically want elements in set such that the value, let's say x is an element in set, the value of x is greater than L and less than R. So we want the count of x. Now in an sorted container, we can get this by finding, let's say I have to find number of elements from 1 to 7 which are present in this. So what I can do is, let's consider 3 to 5. So first what I will do is I will find the number of elements which are less than 6, because we were finding 5. I will find less than 6 or less than equal to 5. Now I got all the elements which are less than equal to 5. Now I have to find 3 to 5, so I will also find all the elements which are less than 3. So this, now I can basically subtract the count of both of these values, and I will get the count of values in that range. And how to get the number of elements strictly less than a specific value in an ordered set? You have to use order of key function of that policy based set. So first of all, this observation, I hope you would have understood this. And if you don't know what ordered set is, you can learn right now, and it is just learn how to use it. You don't need to go deep dive into how it's internally implemented. If you are interested, you can obviously read it, but just learn how to use it first. So let's see the code. This is the template for it. I add some include some libraries and declare an ordered set. Now what I will do is I will declare an ordered set st and initially store all the peaks in that st. Now I'll declare an answer vector to store all the query's answers. Now first key of if the query type is 1, I will first take an ln r. If the size of subarray itself is 2, then I will just push back 0 in this, because in subarray 2, first there is no middle element which has previous element and next element present in it. And if it is greater than 2, I will find the elements which are less than r and subtract it from the number of elements which are less than l plus 1, and finally push the answer. And if the query is of second type, that means I am updating an index value. First I will iterate over 3 elements, that is idx minus 1 to idx plus 1. Then this condition is necessary because it cannot be first or last. First I will erase them, then update the value at index, then again insert if there are any peaks created. So that was about this question. This was, I would say, easier if you know policy based data structure, but there might be a easier solution. I just couldn't think of more easy solution than this. And the contest wasn't that good for me because I made some silly mistakes on second and third problem. So I think that's it from my side, and thank you for watching.